Welcome everyone to the AUTOBLOCKS webinar, introducing TurnBlock, a game-changing rotary robot. Introducing the AUTOBLOCKS team. With us today we have Jared Sandman, President and Creative Director at Fancort Industries and AUTOBLOCKS, Edison Preciado, Global Automation Manager and Custom Machine Building Expert, and myself, Diego Rivera, Sales and Applications. Today's agenda will be a presentation by Jared, followed by a question and answer session and system demo. If you have questions, we will have a live Q&A session at the end. And now I'd like to turn it over to Jared for today's presentation.
Great. Thank you so much, Diego, and thank you everybody for joining us today. I'm really excited about what we're about to share with you today. But before we do that, I think it's important to give you some context about how we came about developing what I believe is a game-changing innovation in custom machine building. So what I'd like to start with is our origin story. And basically, we've been building custom machines for large industry-leading companies in the aerospace and electronics manufacturing. And Edison Preciado and his team, as well as a team in New Jersey, I think we have about 30 engineers now who are building really fantastic machines to make our customers more productive and produce higher quality parts. But along the way, what we've discovered is there's some particular pain points in the industry that I think can be massively improved. That starts with cost. A lot of custom automation can be very expensive, and there's a huge amount of the market that I think can be served by simple modular-based, block-based automation systems that can be deployed quickly, easily, be standardized in a way that is easier for maintenance and scalability, and all these things that I'm going to talk about in a minute. Another pain point is for integrators and people who build machines. Sometimes that's an integrator. Sometimes that's some of the customers out there build systems, basic systems themselves. I think you should have the ability to build your own system. And that often is out of scope for people who have limited internal resources. The purpose of AUTOBLOCKS is to be able to unlock that. So you can have a mechanical engineer who is not a programmer or not an expert, who can design fixtures and do some decent mechanical basic engineering, but doesn't have to be an expert in machine building. And now you should be able to have the ability to build machines. And for integrators, the people who build machines like ourselves, I wanted to, not only did we develop AUTOBLOCKS to make our lives easier as integrators, this is meant to be a game-changing event for integrators. I know some people on the webinar today are integrators, and we want to enable them to grow their business and serve their customers better by using a system that makes their lives easier and more productive. And the pain points for them are availability of trained engineers and time to get things done. So AUTOBLOCKS addresses all of those pain points in a way that benefits ultimately the customer, making your business more profitable and more productive. So with that, what I'd like to do is introduce TurnBlock, the world's most capable rotary robot. And I'll get into it in more detail as we go along here, why we call it a rotary robot, because it actually is substantially more than just a rotary indexing table. In fact, it's a patent pending technology that we think can change everything. And it starts with being unbelievably capable. What I mean by unbelievably capable is, as we've developed AUTOBLOCKS, at every moment in the development process, we constantly ask the question, what more can we get out of this machine? What more can it do? And at times, this was a frustrating process for the engineers who were programming it. They would say, well, it's traditionally done this way, or it's traditionally done that way. And I said, well, let's make it more flexible. Let's make it more capable. And even to my own surprise, we have added unbelievable capability. And one of the things that we didn't set out specifically to achieve, but I believe is one of the most important aspects of the term block, is no code machine integration. That means that your devices, robots, vision systems, barcode scanners, are simply turned on, connected and turned on and off via the HMI without having to know or code a PLC. This is game changing. This means a mechanical engineer such as myself can build a system without having to study and know PLC programming. The next and really critical thing is whenever you're developing a system is you have to define who the master is. You have various control systems in any given machine, be it the vision sensor control program or the robot, etc. Those all have to be controlled centrally so that it can be operated in a safe, efficient manner. The term block acts as the master in any given system. And one of the things it does is it coordinates up to 8 stations. And a station, as you can see in the video here, we have 4 stations or 4 positions on the table, and those rotate through from step to step. But we can do up to 8. So if you think about it, that's quite flexible. We can do more than 8. We can do continuous operation. We can do anything. But standard through the HMI with no code is 8 stations. And you add and subtract devices via a plug-and-place device library. We'll talk about that in a minute, how you add new devices. It includes a really powerful 7-inch HMI PLC. This is not a low-cost PLC. This is a very capable industrial PLC that is hard-coded. You turn on the machine and it powers on immediately. It's very reliable. It's a industry-leading PLC, all inside the term block. It includes an integrated machine base. There's quite a bit to the term block that doesn't quite meet the eye, or there's more than meets the eye, I should say. And that includes an integrated machine base. So inside this sheet metal enclosure is a base plate and a top plate, and they're sandwiched between pillars that are all tool pinned together. So you end up with a very rigid structure so that you can do precise processes on the table with additional blocks bolted to the table. And that eliminates the need for a separate machine base. It also includes a removable UL control panel. So one of the things that we came up early on in the design process is to make the control panel horizontal and removable. That means that all of the interconnects inside the drawer, you take out these 2 bolts you can see there in the video, and you can remove the drawer, and you can take out the interconnects, and you can completely remove it and replace it or send it back for service without having to take apart the larger machine. It includes part and data tracking with barcode. I'll talk about a little bit more about this in a minute. Not only are the parts tracked through the turntable processes as they go through, but you can also associate data with that, including recipe changing. So you can do all your data collection from, let's say, screw fastening. Standard sizes, you can see here in the picture, this is a 24-inch diameter table. Also standard is 36 and 48. But I'm really excited about our recent development, which is to offer the controls as a back panel for integrators or others so that we can do any custom table. So now there's really no limit to the amount of the size or the complexity of the rotary system that we can build. And one really critical thing that we identified in our product development roadmap was to be able to have a turntable that can be lights out or collaborative. And what that means, in this picture, you can see that it has light curtains as well as a barrier wall between the operator and the robot. That would be a manual loading sequence. And there's a very specific algorithm that keeps the operator safe, not only from the high-speed robot, but from the rotation of the table. So when the table is rotating, if it has fixtures on it, and the operator breaks that light curtain, the table instantly pauses. So the operator is safe to load and work collaboratively with an industrial robot. I think that's a really unique feature. But then as you grow and you expand your system, you can eliminate the operator altogether and simply through the HMI configure it so that you don't have a operator, and you run it in lights out or in a batch or a buffered manner. And then the table itself has a huge amount of communication. And we'll talk about this a little bit more in the next couple slides about being able to expand the table, but it has digital, analog, Modbus, TCP, and Ethernet communication, all built in, readily accessible through standard connections. Now, here, I've been giving this presentation to many customers and getting feedback along the way. And one of the things that I often get at this point in the presentation is, it's a rotary indexing table. What's different about it? What is it? There are many people who can build this. I think it's absolutely different. In fact, we are patent pending already. And here's just a few summary points which highlight the difference between the turn block and a traditional indexing table. Obviously, the turn block and an indexing table both have precision gearboxes and powerful servo motors. That's a given. We have that built into the table. But we also include your industrial PLC. This is a very expensive, capable PLC with an HMI. It includes all the software, which is preloaded so that you can accomplish no-code integration. It includes plug-and-play safety, so it has a safety relay built in. It has the managed power we talked about, so that you can turn off power and lock out, tag out safely your machine for shutdown or maintenance. It includes a machine network. So inside the table, you have a network switch, which connects all of your devices at your stations, including the internal connection with your table. Obviously, it has a safety relay, so for your things like your light curtain, as well as your remote devices. It includes the machine base, which is a structure built inside. It's kind of, think of it as like the skeleton or backbone of the table that gives it a high level of rigidity. The UL control panel. So we know we have a well-designed control panel that's safe, and it has pneumatic controls. So you put in one main pneumatic connection, and it distributes via a manifold the pneumatics to the stations. It also includes a pressure sensor so that you can determine if the table has pneumatics, if it has a loss of air, and you can also do a safety pneumatic dump valve. So if somebody hits an e-stop and your particular application requires that there can be no stored energy, such as pneumatic pressure, that can also be easily set up. So quite a bit of difference. You're basically talking about a turntable with the brain. It's the entire brain of the system. Now, a little bit more about plug and play. Obviously, we all know what plug and play is. When we plug things into our laptop or whatever, it should simply work. This was the goal and is what we've accomplished with the TurnBlock software. You have plug and play universal robots, Epson robots, SMC pneumatics, key and safety, and vision and barcode devices. And also, that library can continually and easily expand via the apps. And apps, this is a PLC, and in the PLC sense, an app ends up being something akin to a user-defined function block, and you know what those protocols and those parameters are. And we define those so that we can easily develop new apps ourselves for you, or you as integrators out there. For those of you who are listening, you guys can set up your own apps, and it's all no license. So this PLC is a no license PLC. So that means when you have the code, you own it, and you can upgrade it to a certain extent. You can upgrade the apps. The core code is locked and protected so that it doesn't become corrupted, but it's a no license platform. One thing that we also wanted, and we constantly challenged ourselves during the development process, is to make this thing as expandable and future-proof as possible. And this definitely was a bit frustrating at times. because we keep asking the question, what else can we do? What else can we add? And again, I think it's a credit to the engineers that worked on this, that we were able to make something that is essentially unlimited in terms of its ability to be expanded. So obviously you can add up to 8 robots, whether it be Universal or Epson. And future robots are simply added via an app. So there's no limit even to the robots. You can add up to 32 axes of pneumatic motion, which is absolutely mind-boggling. It absolutely can be. It might not even be able to fit on, let's say, a 24-inch turntable. But again, you can change the size of the turntable, 36, 48, and then if you do a remote control panel, you can do any size. So 32 axis of motion is quite important, and it's a really good, reliable way, low-cost way of adding motion to your rotary system. Rather than adding a robot, you can simply have a pick and place, or you can have something twist or something flip. And I'll talk about that a little bit more in a minute. Also, the amount of I/O that the table has, it has 3 input, 5 output, analog, Ethernet, and Modbus TCP on all of 3 stations. It also has an auxiliary 3 in, 5 out on the rear. And if that's not enough, you can simply use a IO link device, which is basically an Ethernet device that you plug in, and it has a input nodule where you can plug in more digital, more analog, and even IO link ready devices. So Keyence and some of these very sophisticated sensors, they can give you live feedback on their status, and all of that can be added. Power management. We have an architecture so that you can power up to 3 Epson and Universal robots directly from the table. That means our goal is always in our architecture is to have a single cord to plug the machine in. And we think that's really important because we want to have a machine that is completely shut and safely shut down for maintenance, so that somebody doesn't have part of the machine on while part of the machine is off and mistakenly have a shock hazard or something along those lines. So what we've done is we've created an architecture where if you need more power than the table can provide, you can have a sub panel that is a slave to the table. And when you power down that table, it powers down everything. And this was a critical piece of feedback we got from large customers who have very high safety standards. And that's includes expandable safety. So you have safety outputs on each station, and you can use those to flip auxiliary relays, which can power down devices that don't have their own safety. So if you have, let's say, a feeder that has no safety circuit, it just has power, that can be connected to a relay, which can be connected to the master relay in the table. And when you hit that e-stop, everything's off. So you have a completely safe, expandable setup. Obviously, you can add more devices via the app. We've been talking about that. And then the enclosures. We felt that a critical way of designing really flexible, low-cost systems is the enclosure, to the extent you need one on the top. So obviously, if you're using universal robots or collaborative robots, you don't need enclosure. So we wanted to have an option of no enclosure. But when you need an enclosure, we want that enclosure to be able to be bolted on very quickly from standard components such as Vention, 8020, and robot units, your standard extrusion suppliers. You can send them a model. If any of you guys, for those of you who have done it, you can simply send them a model and they send you a kit, either fully assembled or bill of material, and you put it on. So we felt that the enclosures should be built to the machine and therefore very flexible. Another thing that we think is really important, and we wanted to consider right from the get-go with AUTOBLOCKS, is to have it connection, to have it connected via IIoT 4.0. So basically what this means is the machine, as we said, has its internal network, and that internal network can be connected to a local area network via hard connection or via a gate. In this situation, you would buy a gate, and the gate can have even a cellular connection. All that is regulated and controlled by the customer, and there's ISO standards that apply to cybersecurity. So these are safe and secure connections, and they're at your option to connect or not to connect. And when you do, what we've done with the machine is we've configured it so that you can actually monitor your data via no-code cloud dashboards. This is really neat. So you're able to go on, have a dashboard, display your widgets, display your data, download your data to spreadsheets, manipulate your data, or all from any laptop, cell phone, or any website. So you can do that, and you can customize it all no code and access to your data from your machine. And when you do connect your AUTOBLOCKS machine to the internet, you can enjoy remote support. So one thing that we have discovered is that we want to be able to provide maximum support. So if your machine has any issue whatsoever, we want to be able to simply access your machine if necessary and talk you through a remote troubleshooting session. So when you connect, because you have a on-machine network, when you connect that network, we're able to troubleshoot the PLC, read your fault codes, update or improve the PLC software. We can also access anything on that machine network, including vision systems and robots. So the remote support, governed by very carefully configured cybersecurity, is a great way to drastically reduce our response time and your ability to keep your machine running. So of course that includes remote software updates. The AUTOBLOCKS software is a very robust software, but from time to time we're improving it. And after you have a deployment, if you need to add a custom app or something like that, we can develop that app, add it to the core code, and push that update to you, all without having to have a site visit. And because the table tracks parts, you can actually do data tracking or data collection. I mean, and another really neat feature, this is one I think is so neat these days, is that your machine can talk to you. It can tell you what's going on via email and text alerts. So if the machine is down and you're the floor manager, it can text you and say, hey, I'm down. And then you'll know if your machine's down, or if you're running lights out in your home, it can send you an email or a text alert. The emails can also be at the end of the shift. You can have it consolidate all the data from that shift and email it to you. So you don't have to actually get into the machine to get data. It can just send you that data, which is really neat. It's SQL client ready, which means it can be set up to collect that data and push it to a sophisticated SQL database. It also comes with customizable maintenance schedules. So it's a standard machine with standard software, but let's say you have robotic soldering on it where you need a tip that needs to be replaced every few shifts. The machine you can set that schedule, and you can send that alert to you, and it'll tell you when to change that tip. So your planned maintenance, your PMs can kind of be scheduled and set up right through the machine. Fault logging is kind of standard in the industry, but on this machine you also have fault logging, so that if you want to go and you see how often is my machine faulting, what are the faults, you can go to the log screen and see what the fault history is. The result of all this is maximum flexibility. And it's really, again, when we keep asking ourselves how we can improve and what we can achieve, I think as a group, we're always, at least for me, I'm surprised what we're able to achieve. And the same thing applies for the flexibility of an AUTOBLOCK system. Starts with the ability to expand with growth. So if you buy or build yourself an AutoBlock system that is a single or two station, and you want to add an additional station or add capabilities, you can expand as your business grows. That means when you're building your production processes, you don't have to feel like you have to buy a machine to support the capacity it's going to come in 1 or 2 years. You can buy that machine um, for today's production requirements without having to make that investment and potentially that risk of buying something that is looking too far ahead. You can simply expand as you go. Just like any robot, you can repurpose it as needs change. So you can take the AutoBlock and you can change the robots, change the devices, and you can repurpose it. You can combine it with multiple machines. This is a surprising and somewhat unintuitive thing right away. But if you have a turn block, let's say with 3 stations, where you have dispense, screw fastening, and soldering, you can simply, through the HMI, turn on and off any one of these 3 processes. So you can actually think about it as 3 machines in one. You can run just robotic screw fastening, then you can run dispense and then soldering, and any combination of those. So instead of buying 3 machines, you can start with 1 and do all 3, and then combine them in various combinations. And you can even turn on and off stations and do process development. So if you're troubleshooting a station and you don't know what's going on with a particular station, you could turn the others off, simply track apart, run that one process, get it back, and do that back and forth on one process until it's perfect. Then turn back on everything and go back up into production. So really, really flexible. The app-based approach based on station flexibility is really unique. And with any robotic system, you can switch from multiple to multiple products. What this means in practice is you have recipes, so or machine programs. Those machine programs can flip the programs on vision systems and robots. So if you have, let's say, a barcode to run product A, you scan it, it calls all of those programs from those stations according to the barcode, and you're ready to run product A. Now you need to go to product B. You scan the new barcode or you enter the new product ID on the HMI. It flips all of your device programs to the new product. Now, obviously, you may have to change the fixture, or you may need to change the end-of-arm tooling, which you can do via quick change setups, but you have the ability to switch between products via recipes. The next thing is you can scale. So if you can expand one AutoBlock from one system to 2 to 3 to 4 to 8, as you grow that, you can also take multiple AutoBlocks and place them in a cellular manufacturing manner, which is super flexible. You have flexibility within the station, but you have flexibility across machines. So if one is down, you could potentially think of ways where you can have redundant processes or switch processes, change them back and forth. Tremendous ability to scale and be flexible. And then one could even think of multiple AutoBlocks with conveyors feeding between them. So you really have just a tremendously flexible system here. Now what I'm going to do, I'm going to take a few minutes here to go through the software HMI. We're on our 14th revision, and we've spent a lot of time refining the HMI. And the goal here, right from the beginning, was to create an HMI that is intuitive enough that with a few minutes of discussion, an operator should be able to run. It really shouldn't require a big training session. It should be very, very straightforward. So what you see here is the home screen. As soon as you turn on the machine, powers up, you log in, and you see this, and right away, you know it's a turntable because it's got a circle in it, and you see fixtures. It says 8. If you set 4, the other fixtures disappear. So you know I have a turntable, I have 8 fixtures, and the table is home. The home icon says that it's home and it's ready to go. Then what you do, and then just to go through the rest of the icons here, you have your programs up here on the left, your settings screen, your fault screen and your fault reset. You can fault reset directly from the home screen. So if you have a quick fault, let's say somebody opens a door, you can reset without having to drill into several screens. So a lot of maximum functionality at the machine. Obviously your start and stop, and then you have a log out icon here. So you have user control. An operator only has access to the home screen and recipe. Everything else is under an admin controlled separate password, and it logs out automatically after 30 minutes so that you're controlled and secure. So what happens in a turntable situation, you press start and you press the auto button here, which is now lit up on the left-hand side. And you can see the strip on the top lights green. So anybody standing 5 feet away knows exactly the state of machine. Obviously, this is reflected on the light tower as well, but we want this to be very intuitive right in front of the operator on their home screen. And now that it's auto and it's running, you can see the arrow is pointing to the fixture, indicating that it's ready to load. You load a part and it turns green. So you know there's a part there. Then it indexes and you can see the part flow in. Then the arrow is telling you to put another part in. Then it indexes, add part, index, add part, index, add part, index, add part, and so on, until you can see the last part or the first part that you loaded is making its way back to the load position. This is a critical transition point. It comes, and now it's finally made it through all of the process steps, and it's in the home position. Now, it's really important because an operator here could step away, and I need to ensure that that part is removed from the machine and does not maintain its position and continue to process around. So as soon as that last part comes to back to its home position, the arrow flips to an up and tells anybody who comes up to this machine mid-process that that part in the load position needs to be removed. So you remove the part, and then it says, all right, now I'm ready for you to load a part. So this arrow tells you very straightforwardly when you need to load and unload the part. This is really critical for that collaborative process where you have an operator. This arrow in a lights out situation shuts off completely because you don't need it. It's really geared towards an operator. The final step is when you come to the end of a shift and you need to empty the machine. Now you press this P here, which is P for purge. So you have to purge the machine of all parts, which means they need to finish all their steps and come out. When you go to the purge function, now you see a screenshot here where nests are starting to empty out and parts are making their way through. And the up arrow is always pointing up because it's saying unload the parts. And in this mode, you only unload parts and it indexes and it doesn't ask for more parts. So the purge function is a very careful algorithm to make sure that you're able to unload parts safely and keep them tracked the whole way. A little bit more about no-code integration. So you can see here on the right-hand side, we define the positions on the table, the 8 positions starting with front, right front, and so on all the way around. And you simply go to your settings screen, you go to the app selection screen, click on the button where here you see it says SMC 3-axis pick in place. And you click on that button, a window pops up and you're able to select what device you have there. So this is the essence of no-code integration. You simply select what you want and it turns on that communication. Obviously, you plug in that device or change the device in the physical world, but from a programming perspective, it's as simple as that. Now, pneumatic robots. This is really interesting. You can simply add 4 axes of pneumatic motion to any of those 8 stations. And you do that by simply looking at this one simple screen. After you select that, so you go to that station, select that app, and you say you want the SMC pneumatic robot on station in this case, the left station. This screen pops up and you say, where do those actuators, what positions do they need to be when I start up my table, i.e. their home position? So you select an A or B because actuators are 2-position. So you select which position they are, and if some reason you wired it wrong and you want to flip it, you can just go A to B, B to A. You don't have to change the wiring. And you can also, if you only have one axis, 2, 3, or 4, you just select NA, and it just comments out that area of the code. So you don't need to, so you can have 1 to 4. And then once you select your home position, you simply go to this table here and turn on the position of each actuator in a sequential nature, starting with row 1 through 8. And what you do is change from if it stays the same position, if you go down one row and it's AA, that means the actuator doesn't move. If it flips from A to B, then you get a motion, and you can have a dwell time at each position. So you can, if you think about it, you can go pick, place, over, pause, down, pick, place, over, down. And you can do all of that simply through this screen. So again, that's 4 axes times 8 stations, 32 total axes. And these can be rotary, linear, gripper, any type of pneumatic motion, 2-position, 2 sensors. These built into this in the back end is position sensors for each axis. And when the robot moves, if it has a hang up or it doesn't achieve that position, you'll get a fault code on the HMI. So you even have fault handling built into the pneumatic motion. So basically, the possibilities are really endless. And as long as it can fit on a table, and it's 1 to 8 steps, and the table can be 24, 36, 48, 6 foot, 8 foot, whatever size diameter you want. If you can fit it on a table, it can be handled with AUTOBLOCKS. And so the possibilities are just endless. Shown here is a 24-inch. 36 is basically the same thing. It's not a lot of, it's basically the same structure in an expanded format, and it's not substantially more money. It's just basically the size of the enclosure in the table. The gearboxes are, there's 3 gearbox options with 10, 5, and 3 arc minute backlash. So really, really precise planetary gearboxes. These are German gearboxes that are extremely precise. Now here, just to kind of get your mind flowing, you know, you can, we have designs here that AUTOBLOCKS provided for side and rear blocks that bolt on directly. And then this is about just to give you a scale here, this is about 4 feet deep by probably about 3.5 feet deep by 5.5 feet wide. So as big as most batch industrial machines you can fit by just bolting this together, and you can put stands under it, or bases, or additional control panels. You can do your enclosures on top, and you can bolt directly. These are our design side block designs, which you can purchase from us. But for the integrators out there, if you want to use extrusions or your own plates or any other creative design, it can bolt directly to the table. It's really up to you. And you can start with something simple. This is basically a rendering of the machine that you'll see in a moment. This is a screw-driving single station, basically desktop. It's very lean, it's very low cost, and it can be put on a desk. And then in the future, when you need to redeploy or expand, you can expand this in all directions and put it on a base. So the same thing can take a little desktop and you can grow it into a full-size machine. So this is just another example of a system we've designed. So you can do blow feed screw fastening, multiple robots. This is kind of 2 robots, so you can do 3. And you can set it up lights out or collaborative. So in this case, you can see you can have 2 robots and you can have an operator standing in front of it. And you can get the benefits of high-speed robots, which are these days Epson robots and other robots that are out there are very low cost, highly capable. And you can leverage that with an operator and still work in a safe manner. Or you can change it over to be a lights out situation. And what you're going to see in the coming months, we're going to do webinars where we show AUTOBLOCKS built with flex feeders, conveyors, the whole 9 yards. We'll be going to Apex in the next couple months, and we'll have those machines ready, and we'll be displaying those. Here, this is just again to kind of stimulate your thoughts. Obviously, you can put universal robots on or any collaborative robot without an enclosure. You can do niche processes such as induction. We have an induction sister company called RDO Induction. And here you see induction reflow, induction heating with Japan Unix wire feeding. So in this case, you put a part on, you would solder one side with wire and induction, it would flip over and you do it, and then off on the left-hand side. Here's an example of a pneumatic pick and place. So if you want the operator to be really productive, they can simply load very quickly, and the pneumatic robot can unload. Or you could have an inspection process where you inspect and then it tracks the data, says good or bad, and the pneumatic robot can pick and place into a bad bin or a good bin. So there's really just a lot of wonderful things that you can do with the turntable. This is a rendering of the machine that's being built here, and we're ready for demonstration in about 4 to 6 weeks. This is a TurnBlock 24 with a Epson robot, with an Epson camera vision system, picking from a flexible feeder, placing it onto the table, inspection with a Zebra vision camera, and then the pneumatic robot picking, placing it onto a conveyor and feeding it back. This is obviously a circular process, but it demonstrates the kind of capabilities that you can enjoy with AUTOBLOCKS. And then you can see here, it's the same machine. You can put a full enclosure around it, so you can imagine it more than just a desktop. It can be integrated, and these enclosures end up becoming very low cost with AUTOBLOCKS because basically they're extrusion only, and they can be non-structural work surfaces, or not. Or they can be just basically either laser cut or water jet work surfaces, because the TurnBlock ends up being your mechanical anchor. Here's an example of a system where you can do amazingly high volume production. So you can in-feed, let's say, 2 parts of a consumer bottling application, and a vision system and a robot can pick and place, assemble them on the table. This is a 36-inch TurnBlock with a label applicator, ultrasonic welding, and then pick and place, unload. Just another example of things that you can imagine. Another niche one, just to kind of continue to show the flexibility. This is induction brazing. So an operator loads parts. It is inductively brazed, and then it's cooled in the subsequent stations. The temperature is measured before it's presented back to the operator. So you can do brazing in a very safe way to make sure operators are safe from burning hazards. All right, and one last slide here, and then we'll transition to our machine demo and Q&A. Eddie Preciado is going to handle the Q&A. He'll be taking live questions, and he'll also be available as an expert panelist. But just to kind of preview some of the webinars that we're going to be having, we're going to have a demo day with the Epson and UR systems that we were showing in the renderings there. Those are going to be universal robots, the Epson with vision, pick and place. So we'll do the same webinar format in a shorter format, focused on machines that we're building. And with that, what I'm going to do is I'm going to transition my camera here, and I'm going to stop sharing. And I'm going to change my background. All right, guys. I think everybody can see me here. So what we have here is a couple of AutoBlock systems that we've recently built, just to kind of show you in real life what we have here. So this is our most recent development. This is a 24-inch turn block table with your 7-inch HMI, your lockout, tagout, your e-stop, and your start and stop buttons. Ethernet connection in the front. Then what you have here is your Keyence light curtains, and you can see here there's a Keyence factory cable that you order direct, and you simply take this, plug it directly in, and it works. You have your door switch. So your door switch is also plug and play. It's a RFID door switch here. It's one door switch right now, but you can daisy chain as many as you need. So you can expand your enclosure and have multiple door switches. On the other side here, we have our part presence sensor. So you can see as I take the part in and out, the machine recognizes the part in the fixture, which is really critical for rotary processes. We have our screw fastening controller here, XPAC ASG, also a partner of AutoBlock's. You can see this machine was built in collaboration with them, and we brought this to a trade show. In the back here on the right-hand side, we have our I/O and our power and our Ethernet connection, same on the reverse side and the left-hand side. And then over here, we have an inductive soldering machine. This is another configuration where you put parts in. Again, you got the light curtain, the part presence sensor. It indexes and it solders. This has a pneumatic single axis up and down for the coil, where it solders the part, and it makes it around where it cools and it presents it back to the operator. And you can see here, parts are in the machine and it recognizes all the parts. If I take this out, it recognizes a part was removed. I put a part in, it recognizes the part is there, and it indexes. And then you'll see the robot start. So that's basically our machine demo. I think what I'd like to do now is turn it over to Edison, and now I'll take your live questions.
Excellent. Thank you, Jared. So we do have some questions here. I'm going to start, but there's a question here that says, give me 1 second. It says, what types of processes are compatible with AUTOBLOCKS systems? Well, so basically, just to answer the question, is pretty much that can, anything that can fit within the size of the table, and obviously the blocks, you can have, during the presentation, Jared mentioned pick and place, screw fastening, robotic dispensing, soldering, basically you name it. We try to stick with the most common applications because we don't want to overwhelm the system by including 20 applications in the same thing. You'd be looking at a more like different robust system, and this is where our automation team will kick in. The goal of this thing is just to simplify the process and not make customers wait like a month or 2 months to come up with a proposal. So basically the goal is just to simplify everything and then just make something quick money, quick turnaround for everyone, a win-win. So basically anything they can think of within that size. The next one, it says, is the turn block station blocks stiff enough and heavy enough for high-speed robots? Yeah, the answer is yes. Obviously, every application is going to be different. And as you can see, the table's made like of like stiff metal. And if you had something crazy, crazy fast, like a Delta robot or something, we would just calculate the base. We wouldn't just put it on a wood table. We would just do a calculation, have a proper structure. But yeah, the answer is yes. It is not a toy. It's not a Chinese made product with low quality. It's US made, designed in the US. So really good
Yeah,
quality.
I think the table itself is probably about 150 pounds. You can't even lift it. And if the robot moves at pretty high speed, you'll still be okay.
Okay. I have a bunch of questions here. Okay, which ones? What is the weight capacity of the turntable, or is this scalable? That's a really good question. And in fact, it depends. We've calculated, you could even have like a press fit station, like a press fit, because the core, it's not just like an empty shell. You have a proper, like a well-designed structure. It's calculated. And you're gonna have payload. Let's say you're gonna apply some pressure to the table. It's not like it's like floating in there. Obviously, you have like a back pressure, you have like a floating plate that actually helps you, solidify that. So you can have like a press fit station or something. Obviously not tons, but it'll be stiff enough just to withstand the pressure. Screw fastening or dispensing, and even some eyelet inserts or something that is not like crazy high volume production, that still can be manageable with this. How do I mount robots or other accessories to an auto block? Also, I believe during the presentation, Jared mentioned this. You have the base block, which is what's considered like the rotary robot. That's pretty much just the core of it. It's just a table that rotates, but obviously that serves no purpose. Of course, you're gonna need some blocks. So those are the attachments. So the structure comes with blocks on the side. Those are like a mounting, like rails, if you will. It comes with threaded holes and pins, so you can, safely just change the blocks and just adapt, and you can just play with the combinations. There's been times where you can just simply attach blocks to the side, or you can just simply have the rotary table mounted on a plate and just simply mount the robots on a pedestal on a separate plate. So yeah, you can play with it's like playing with Lego blocks for automation, pretty much. Oops, there are a bunch of questions here. Is there a minimum requirement if I use this for machine build so far as 15 years ago? I'm having a hard time understanding that question. Is there a minimum requirement if I used this machine? If I use this for machine build so far as 15 years ago, can you clarify, what the more like the question? I'm having a hard time understanding that. I'm sure if you can pick that one up, Jared. Did you get that one?
I guess what I would say is there is no minimum. We build these. It's actually a good point to bring up. For the integrators out there, even customers benefit from this. Whether you're buying turnkey from us or buying turnkey solution of AUTOBLOCKS from an integrator, because we will have, and we are, some of the gentlemen on the call today are potential certified system integrators. The idea is we build these in volume so that they are cost effective for everybody, including integrators. There is no minimum quantity order, but what we do is we build in batches of 5 minimum to achieve economies of scale internally, and then we pass those savings on to our customers and our integrators.
Excellent. All right, so there's another question that says, can I adjust the speed and acceleration of the block turntable? Yes, the answer is yes. Like a robot, basically, you can just play with the speed. You can just pretty much a servo motor. So it's a very sophisticated gear.
Minor comment on that. Speed is, or acceleration, deceleration will be driven by a moment of inertia calculation. So when you're, so we have 3 different backlash gearbox options, but we also have 2 different size servo motors that we can simply change in and out. So your maximum XL decel will be determined by the inertia or the amount of load on the table itself. These are oversized, so you can this gearbox in this 24-inch table is sized to turn a 36-inch quarter-inch piece of steel. So it's really oversized. But just to be aware, there are limits to XL and decel based on the laws of physics.
Perfect. All right. So someone else was asking if they were gonna be able to access the webinar at the right after I just said yes. I answered that privately. There's another question. It says, can a barcode be used to determine the operation for a specific customer part? Similar to a contract. Oh yeah, of course. Yeah, we do this all the time. So basically, we have capabilities to expand. You can have like local storage. You can simply just, every time this happens, if you wanted our team just to communicate with your team, we would just have to see what your IT department like specs looks like and how do you want us to handle and process that information. It's what we call like traceability. You can have all sorts of data, something that we call SPC, which is it stands for statistical process control. And basically you have a nice dashboard when you'll see good parts, bad parts, scrap parts and everything else, first pass yield. There's tons of information we can send at the end of the webinar like a compressed information where you can see all of that, and definitely you'll have traceability. How accurate? This question is going to be for you, Jared, because we have the multiple backlash
Come on,
gearbox.
test me. Let's go.
How accurate is a rotary table? Is there a locking device to fix the position of the rotary table? I really like this question.
Perfect. So we have a 71 gearbox gear reduction ratio, right? So already you have such a ratio between the speed of the motor and the speed of the table, it's almost self-locking. And then from there, it's a servo motor, so it basically holds position. And then in terms of we got to be careful about the word accuracy and repeatability. What I generally talk about is repeatability, and in terms of rotary position, that usually translates into backlash. Backlash is the space between gears as they're moved from a front load or one load position to the other. So these are precision gearboxes with 3 arc minute of backlash, which is really, really small. On a 24-inch table, you have to run the numbers. I don't want to say because somebody's going to run the numbers after, but it's in the thousands of inches of backlash here. And you can see here, like if I pull this table, there's no backlash here. There's literally none. So that's repeatability. If we were to build something really large, let's say really high speed, 6-inch table, in that case, we would take all of the guts of this, build a custom machine, or an integrator could. In fact, we would love to support integrators to build these systems. But basically, then you could go to a cam-driven gearbox, which is 0 backlash. So you can really accomplish quite a bit.
Perfect. All right, the next question is, let me just move this to the side. Does the turn block table provide power to machine blocks and accessories? Yeah, the answer is yes, I believe. Correct me if I'm wrong, it's 5 amps.
Yep, it's 5 amps. So what you have is you have 240 20 amp input with a main circuit disconnect, then it branches out to station branches, which have their own circuit breaker. So it's all designed correctly. And then you have 5 amps. 5 amps at 220 volts is enough to support directly the Epson T3 and the universal 3 and 5 and 10 direct power. Then if you go to multiple accessories beyond that, what you do is you have a slave panel that takes the main power and distributes it to your robots that wouldn't be supplied by this. And then what you do is you use your safety circuit to connect to a disconnect contactor that kills power to that sub panel. So you can do it all safely and you can scale your power.
Perfect. And now I have a bunch of questions. Let me choose one. How do you handle multiple parts to be assembled with feeders and vision? That's a good question. Yeah, it's actually a good question. Basically, how do we handle multiple parts? So the way to do it right now, obviously, it depends on how you feed the material, right? So if you're just gonna do like a pre-assembly where you have a housing, you say you have your fixture at the front, and you're gonna do some sort of let's say a screw fastening and inspection. So if you're gonna have an operator at the front of the station loading the part, let's say the housing or the vase, and loading the PCB, if we're gonna make some assembly like that, no need for vision, no need for nothing. If you're gonna do like a pre-assemble, Obviously, there are going to be stations that they're going to validate that the parts have been placed correctly and whatnot. Now, if we're going to do automatic feeding, that's a different thing. You're going to have a block on, like a block or device on the side, depending on what we use. We always go with 2 brands, and this thing comes with a backlight, and we have a robot with vision guided mechanism. So basically, you go, you train the system, where you just simply define the shapes, or the position, the okay or not. So if you just dump a bunch of parts in this vibrating hopper, it's not just going to get confused and just pick parts randomly. You just program that, and it's going to go find the pattern. And once it hits the pattern, it doesn't matter if the part's rotated. The robot, that's why, if we're going to use a SCAR robot, the 4th axis can come in, just rotate, use the gripper, and then automatically place it anywhere you want. That's for part feeding. And for part validation, that would be a separate vision system or vision sensor, depending on how much your budget is and whatever you want to target. If you want to measure, or you just want to validate, okay, presence, not a present, or pattern recognition, that kind of thing. It's pretty much all scalable. That's why it's very good having discussions when it comes to an application, because we can just listen to your goals, and based on the goals, the timeline, and whatever ROI or budget you're trying to hit, we can just play with the hardware we have. We have tons of partnerships, and we can give you tons of options. The same system can cost, just to give you a number, 300,000, or it can cost you 150. It depends on how much money you want to put into this and how reliable you want the system to be. Someone says, shout out to RDO. That's good. All right. All right. This is a good question. I think it's a future development. Is there going to be a standalone controller option?
Haha. Yes, sir. Yes, sir. Absolutely. So what happens is this architecture can be in any form factor. This is a built-in HMI and PLC. Once you go to the 36-inch frame, what we do, you don't see it, but we do the PLC on a DIN rail, and the HMI is separate. So if you think about it, instead of being, there's a removable drawer obviously in here that you pull out. That could just be a vertical control panel with all your devices on it, and that can be a module on its own. And that's essentially the next product we're going to bring out.
Perfect. And I have, I don't know how much time do we have still? Are we okay in time?
Maybe 2 more questions, and then we'll wrap it up. And maybe we send if you guys want to keep asking questions, Eddie, Diego, and I will be available after this. We'll send out an email, and you can contact us with your projects or questions moving forward.
Perfect. You know what? I think I have a good question here for you that you can answer by pointing what you have right next to you. So it says, how are the robots controlled by the turn block?
This is a great question.
Yes.
So we spent a lot of time on system architecture layout, and essentially what it boils down to is, if you start with the turntable PLC as being the master, and this is why rotary automation is able to be standardized, whereas linear is not as easily. So essentially, when you put a part in and that part presents itself to the, let's say, the rear station or the side station, there's what we call like a handshake. And what we did is we defined that handshake really strictly. That handshake communicates via Ethernet IP or Modbus, and then it tells when you start the machine, it makes that device initialize. Let's say a robot go to its home position. Then the robot says, "I am home and I am ready." Then when the table indexes and that part is in front of the robot, it tells the robot start. The robot does the process and then returns a handshake that says I am finished. During the handshake process, when it's running, you also have fault code handling. So when that robot is running, if it faults out for any reason, mechanical or software, a fault code triggers a fault on the HMI. So it's a very straightforward handshake that tells it to start, and then it tells the tables when it's finished. And then the final piece that coordinates everything is the table looks for all stations to be complete before it indexes. That's a critical aspect. because when you have multiple robots, it will index at the speed of the slowest process. That includes the operator. If the operator is very slow or takes a break, the machine will pause and wait for the operator. So the operator, if they're fast, then it'll be gated by the slowest process on the machine. If they're slow, then it'll be gated by them. And that's really the natural way that things need to be set up in a rotary system.
Perfect. All right. And I have one last question for you that goes back to the 3-axis. We talked about having like up to 32 axes of motion. And someone's asking, how would you program the 3-axis SNC gantry, which is a very basic gantry?
So first of all, just make sure that what we're talking about is pneumatics. Coming soon will be servo or stepper axes, so truly programmable axes directly via the table. That is definitely coming. But what we're talking about here is SMC pneumatic two-position actuators. So what you do, I earlier in the webinar, we'll send it, you can look at it. Basically, those actuators have a position and a B position. And what you do is you have a sequence, basically a table where you say that any given axis is in its A position, and then as you step through that sequence, it either stays in that position or moves to its B position, and it has to achieve that position. And the position sensor should read that it's achieved its movement in a very short amount of time, or you get fault at the table. So the way you program it is A or B position in a sequential table that steps through your sequence 1, 2, 3, 4, 5, 6, 7, 8.
Very good. That was the last question we have.
All right.
Yeah.
Well, thank you everyone for joining us. I really appreciate it, and I look forward to working with you on AUTOBLOCKS. Bring us your opportunities. We're excited to get started.
Yes. Thank you, everyone. Have a great day.